According to the National Electrical Code, using a junction box on an arc fault circuit interrupter (AFCI) circuit for regular circuits is not permitted. The National Electrical Code specifies that a junction box on an AFCI circuit is designated exclusively for other AFCI circuits. Connecting regular circuits to a junction box that is part of an AFCI circuit is not compliant with the Electrical Code. National Electrical Code Section 210.12 subsection S stipulates that each branch circuit must be protected by an overcurrent protective device. This protective device must be rated not exceeding the ampacity of the circuit conductors. It must also be either of the inverse tan type or the instantaneous strip type. This requirement ensures that branch circuits are adequately protected from overcurrents that could lead to hazards like fires. National Electrical Code Section 408.30 subsection M mandates that AFCI protection be provided for all 15 and 20 ampere 120 volt branch circuits that supply outlets or devices installed in dwelling units. This provision aims to enhance electrical safety in residential settings by mitigating the risk of arc faults, which are a common cause of electrical fires. It is a critical safety measure to protect homes and occupants from electrical hazards. National Electrical Code Section 408.4 requires that an AFCI be installed in a readily accessible location. Acceptable locations include at the panel board or in a junction box. This accessibility is essential for maintenance, inspection, and troubleshooting. It ensures that the AFCI can be easily reached when needed, facilitating timely intervention in case of any electrical issues. Therefore, based on these provisions, the National Electrical Code does not allow regular circuits to be connected to a junction box on an AFCI circuit. This restriction is in place to maintain the integrity and safety of the AFCI protection system and prevent potential electrical hazards. Using a junction box intended for AFCI circuits for regular circuits compromises the intended safety measures and is a violation of the Electrical Code. The reason for this separation lies in the nature of AFCI protection. AFCI devices are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. These devices are specifically calibrated to recognize the unique characteristics of arc faults and to trip the circuit when such a fault is detected. Mixing regular circuits with AFCI circuits in the same junction box can interfere with the proper functioning of the AFCI device. The presence of regular circuits can introduce electrical noise or other disturbances that can mask the arc fault signature, preventing the AFCI from detecting and responding to a genuine arc fault. This can render the AFCI protection ineffective, increasing the risk of electrical fires. Furthermore, the use of a junction box intended for AFCI circuits for irregular circuits can create confusion during maintenance and troubleshooting. It can be difficult to distinguish between AFCI and regular circuits in the same junction box, making it challenging to identify and resolve electrical problems. This can lead to delays in repairing faulty circuits, increasing the risk of electrical hazards. In addition to the technical considerations, there are also practical reasons for keeping AFCI and regular circuits separate. AFCI devices are generally more expensive than standard circuit breakers, and they are often installed only in specific locations where arc fault protection is required, such as bedrooms and living rooms. Using a junction box intended for AFCI circuits for regular circuits can lead to the unnecessary installation of AFCI protection in areas where it is not required, increasing the cost of the electrical system. Therefore, it is essential to adhere to the National Electrical Code and keep AFCI and regular circuits separate. This will ensure that the AFCI protection system functions properly and that the electrical system is safe and reliable. When installing or modifying electrical circuits, it is always advisable to consult with a qualified electrician who is familiar with the latest edition of the National Electrical Code. A qualified electrician can ensure that the electrical system is installed in accordance with all applicable codes and standards, providing peace of mind and protecting against electrical hazards. Here's a more detailed breakdown of the relevant National Electrical Code sections. Firstly, National Electrical Code Section 210.12 subsection addresses the arc fault circuit interrupter protection requirements for dwelling units. This section mandates the installation of AFCIs to protect branch circuits supplying outlets or devices in specific areas of the home. The purpose of this requirement is to reduce the risk of electrical fires caused by arc faults, which can occur due to damaged or deteriorated wiring, loose connections, or faulty appliances. Arc faults are characterized by unintentional electrical discharges that can generate high temperatures and ignite nearby combustible materials. AFCI devices are designed to detect these arc faults and quickly interrupt the circuit, preventing a fire from starting. Secondly, National Electrical Code Section 408.30 subsection specifies the types of branch circuits that require AFCI protection. This section states that all 15 and 20 ampere 120-volt branch circuits supplying outlets or devices installed in dwelling units must be protected by AFCIs. This includes branch circuits that serve lighting receptacles and other electrical equipment in bedrooms, living rooms, dining rooms, family rooms, and other areas of the home. The requirement for AFCI protection applies to both new construction and existing homes when the branch circuits are extended or modified. Thirdly, National Electrical Code Section 408.4 addresses the location of AFCI devices. This section requires that AFCIs be installed in a readily accessible location such as at the panel board or in a junction box. The purpose of this requirement is to ensure that AFCIs can be easily accessed for testing, maintenance, and troubleshooting. A readily accessible location allows homeowners or qualified electricians to quickly identify and address any issues with the AFCI device, such as nuisance tripping or failure to operate properly. In addition to these specific National Electrical Code sections, there are other general requirements that apply to the installation and wiring of electrical circuits. These requirements cover topics such as conductor sizing, overcurrent protection, grounding, and bonding. It is important to comply with all applicable National Electrical Code requirements to ensure that the electrical system is safe and reliable. Here's a more practical scenario to illustrate the importance of following the National Electrical Code. Firstly, consider a situation where an electrician is wiring a new bedroom in a home. The electrician installs a 15 ampere 120-volt branch circuit to supply power to the lighting and receptacles in the bedroom. According to National Electrical Code Section 210.12 subsection A, this branch circuit must be protected by an AFCI device. The electrician installs the AFCI device at the panel board and connects it to the branch circuit conductors. Secondly, the electrician notices that there is an existing junction box in the bedroom that is already being used for a regular 20 ampere 120-volt branch circuit supplying power to a window air conditioner. The electrician decides to save time and money by using the same junction box to connect the new AFCI-protected branch circuit. The electrician wires the new AFCI-protected branch circuit into the existing junction box, along with the regular branch circuit for the air conditioner. Thirdly, a few weeks later, the homeowner experiences problems with the AFCI device tripping frequently. The homeowner calls an electrician to investigate the issue. The electrician discovers that the AFCI device is tripping due to electrical noise generated by the air conditioner on the regular branch circuit. The electrical noise is interfering with the AFCI device's ability to detect arc faults properly. As a result, the AFCI device is tripping unnecessarily, causing inconvenience and frustration for the homeowner. The electrician explains to the homeowner that it is not permitted to use the same junction box for both AFCI-protected and regular branch circuits. The electrician recommends that the homeowner install a separate junction box for the AFCI-protected branch circuit to isolate it from the electrical noise generated by the air conditioner. The homeowner agrees to have the electrician install a separate junction box for the AFCI-protected branch circuit. The electrician installs a new junction box and wires the AFCI-protected branch circuit into it. After the new junction box is installed, the AFCI device stops tripping frequently, and the homeowner is able to use the lighting and receptacles in the bedroom without any further problems. This scenario illustrates the importance of following the National Electrical Code and keeping AFCI-protected and regular branch circuits separate. Using the same junction box for both types of circuits can lead to electrical noise and interference that can compromise the proper functioning of the AFCI device. In addition to electrical noise, There are other potential problems that can arise from mixing AFCI-protected and regular branch circuits in the same junction box. For example, if there is a ground fault on the regular branch circuit, it can cause the AFCI device to trip unnecessarily. This is because AFCI devices are designed to detect ground faults as well as arc faults. Similarly, if there is a loose connection on the regular branch circuit, it can create an arc fault that can cause the AFCI device to trip. Therefore, it is always best to keep AFCI protected and regular branch circuits separate to avoid any potential problems. If you are unsure about how to wire electrical circuits properly, it is always best to consult with a qualified electrician. A qualified electrician can ensure that the electrical system is installed in accordance with all applicable codes and standards, providing peace of mind and protecting against electrical hazards. Additionally, ensure that the location of the panel board or any junction box where an AFCI is installed is readily accessible. This means that it should not be obstructed by furniture, storage items, or other objects that could make it difficult to reach the AFCI device. A readily accessible location allows for quick and easy access to the AFCI device for testing, maintenance, and troubleshooting. Testing AFCI devices regularly is crucial to ensure they are functioning correctly. AFCI devices have a test button that can be pressed to simulate an arc fault and verify that the device trips as intended. It is recommended to test AFCI devices at least once a month to ensure they are providing adequate protection. If an AFCI device fails to trip when the test button is pressed, it should be replaced immediately. Also, be aware of the signs of a potential arc fault. These signs may include flickering lights, discolored outlets or switches, burning smells, or unexplained electrical shocks. If you notice any of these signs, it is important to investigate the issue immediately. Turn off the circuit breaker for the affected circuit and contact a qualified electrician to inspect the wiring and equipment. Ignoring the signs of an arc fault can lead to a fire or other serious electrical hazards. When working with electrical circuits, always take precautions to protect yourself from electrical shock. Turn off the circuit breaker for the circuit you are working on before touching any wires or equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical circuits when you are wet or standing in water. Electrical shock can be fatal, so it is important to take all necessary precautions to protect yourself. Finally, remember that the National Electrical Code is a complex and ever-evolving document. It is important to stay up to date on the latest code requirements to ensure that your electrical system is safe and compliant. Consider taking continuing education courses or consulting with a qualified electrician to learn about the latest code changes and best practices for electrical safety. By following these guidelines, you can help to protect yourself and your family from electrical hazards.